Okay, this is the non-calculated paper. It is the 4th of November 2015 and it is the higher tier for Excel. I'm just going to talk you through the whole paper and go through the answers in as much detail as I can without spending too long on each one. Forgive me, I do have a cold. We'll see how we get on. Question 1, I'll read it out to you. Sean wants to go on holiday. He's going to get a loan of £720 to help pay for the holiday. Sean will have to pay back the loan plus interest of 15%. First thing I do there, I just work out what 15% is. I don't know exactly what I have to do yet, but chances are it's all part of it. There's how you find 15%, 10% and 5%, add it up, so it's £108. He's going to pay it back in 12 equal instalments. So he's going to pay back the £720 plus the 108, which is 828. And if he's doing it in 12 equal instalments, you need to do 828 divided by 12. And I've done that there using the good old-fashioned bus stop method. And the answer is £69. There's 4 marks for that. You will get 2 marks for doing the 15%, and you get the rest of the marks for showing your workings for the correct answer. Even if you can't do the long division with the bus stop method, at least find 15%. Question 2. Use the fact that 5.4 times 36 equals 194.4 to find the value of 5.4 times 3.6. The way I do this is lots of ways, but the 5.4 is the same, but the 36 goes to 3.6, so it's what we call a factor of 10 smaller. So the answer is going to be a factor of 10 smaller. So move the decimal point across, it's going to be 19.44. The next one, the 54 has got 10 times bigger, and the 36 has got 10 times bigger. So the answer is going to get 100 times bigger because you move the decimal point twice. So that's why it is 19,444. Next one is sequences. You either know these or you don't really. It's going up in 6s, so it's 6n. First thing you write. That's your first term, so 6 times 1 is 6. What do you add to 6 to get to 11? You add 5, so it's 6 and add 5. Check it for the next one. 6 2s are 12, add 5 gives you 17, so you've got 2 marks for that. The next one, people often lose some silly marks on. Is 121 a term in this arithmetic, don't worry about that word, sequence? You must explain your answer. No, it's not. And my explanation is that the 19th term is 119 and the 20th term is 125. People often say, well, how do you know to go for those two? Well, you just a bit of trial and error really in your head. I started with the 10th term. That will be 65. 6 times 10 add 5 is 65, so it's a bit low. Went for the 20th term. 6 times 20 is 120, add 5 gives you 125. Because it's going up in 6s, look, the 19th term, you just take 6 off. So 121 is between those two, so it is not in the sequence. So you get your marks for the workings. You get no marks if you just say no. Next page, there are some black pens, some blue pens and some red pens and some green pens in a box. The table shows the probabilities that a pen taken at random will be the colours. So there's your probabilities. Whenever this question comes up, I tell my students, just fill that M1 in. You're gonna be asked about it. So it's got to add up to 1. So that is 0.3. That's 0.5, 0.9. So it's 0.1. We'll use that in a minute. Work out the number of black pens. So there's 200 in there. Probability is 0.3. So it's 200 times 0.3, which gives you 60. If you're not confident doing that calculation, don't be afraid to convert 0.3 into 30%, because 30% of 10% is 20, so 20 is 60. The next one, a pen taken as random from the box, the probability it will be green is, as we discussed there, 0.1. Some people put in things like 10%, that's fine. You put in 1 over 10, that's fine. But I don't see why you'd want to change it from the format it's been given to you in. So leave it at 0.1. Question 5. I found this one a bit fiddly, I'll be honest with you. Here are the ingredients needed to make 8 shortbread biscuits, so that's in the middle. Tariq is going to make some shortbread biscuits. Why not? He has the following ingredients. So that's what he's got in his cupboard. He's got 330 grams of butter, 200 grams of caster sugar and 450 grams of flour. Work out the greatest number of biscuits he can make. I didn't really know how to approach this one because there's some quite tricky division things here. If you work out how much it is to make one biscuit, it doesn't work very well. 60 divided by 8 doesn't go very nicely. So what I did, I just tried, well, if that's 8 biscuits, 4 biscuits is that, because you half it, and then I noticed you can half these again, so 2 biscuits is that. So all I did was, I looked at how much butter he would need and how many we can make, and for 8 biscuits he needed 120 grams, so great, he can do that. For 16 biscuits he'll need another 120 grams, so 240 in total. Fab, and he's got loads of it left, look. Then I added on another 4 lots, so that would be 60 grams, so that got to 300 grams, and then I noticed you can make another 2, look, over there, because 30 grams of butter, so add another 2 on. So we can make 22 biscuits with his butter. I did the same thing with the caster sugar, look, 8 biscuits, he needs 60 grams, he's got 200, look, 16 and 24, look, just 3 lots of the 60, so that's 180. I then noticed the 2 biscuits is 15 grams of sugar, so that's all I went up to. I went up to 195 grams, but he could make 26. But the question says what's the most he can make, so our limiting factor is still 22. Until we look at how much flour he's got. So he's got 450 grams of flour, so he can make 8 biscuits with 180 grams. So with you make 16 biscuits, look, with 360 grams, because I've just doubled that up there. And I can't add another 180 on because it'll go over 450. But I did notice I can add 90 on there, look, to take it up to 450, which will be 20 biscuits. 8 add 8 add 4 up there. So the answer is he can make 20 biscuits because he'll run out of flour first. And I've just written 20 down there. That is there's your workings for it. This next one is quite nice. It comes up all the time. And this is pretty much the answer on the page, you can see, but I'll talk to you about in what order I did. There's a few things you'll notice here. It's an isosceles triangle knocking about in the middle, so that means that this length here is the same as this length here. But the first thing I did, if that's 70, then that's going to be 70, because these 2 lines are parallel. That's what those little arrow things mean there. They're like train tracks. So, and I've labelled that, look, it's a Z angle. I've even drawn the Z in case you can't see it. But you've got to use the proper name, so it's an alternate angle. So that's step 1, getting that 70 is an alternate angle. Step 2, because I mentioned it's an isosceles triangle, that means the angles at the end of the equal sides are equal. So because the angles at the ends of the 2 equal sides in an isosceles triangle are equal, that will be 70, because that's 70, that's 70. So this one here is easy now. 180, take away 140, 70, gives you 40 degrees. Because there's 180 degrees in a triangle. So the answer is 40 degrees, and I've written that down there. This is one of the questions where you're assessed on the quality of your written communication, because up there by the question number there's a star. I'll zoom right on it. There you go, look. So it's a little asterisk next to it. And on the front of your exam paper it will tell you that you are given marks based on the quality of your written communication. If you've never read it, it's down here, look. Questions labelled with an asterisk are ones where the quality of your written communication will be assessed. So it's very possible to get a lot of marks on this without even getting the answer right. So I'm not really getting the marks for the 40, I'm getting the marks for all the explanation I'm doing here. I expect you'll get 2 marks for that bit because it's your alternate angle, that's a tricky one. You'll get 1 mark for pointing out that 70 because it's an isosceles triangle, and you'll get 1 mark for doing the 180 degrees in the triangle thing. But you must say what you're doing as you go along, because like I said, you're assessed on it. Question 7, moving on. Lovely, questionnaires come up. There's always some idiot who's written a stupid questionnaire, so let's have a look. In this case it's Martin. He wants to find out how often students use the local tram service. So how often do you use a local tram service? A little, sometimes a lot. Write down 2 things wrong with it. There's loads of things wrong with it, but the most obvious things are there's no time scale, so how often do you use it per week, per month, per day even. There's no option here for I don't use it at all. So if you don't use it at all, you can't tick on anything. So we're asked to design a better questionnaire for Martin to use, so this is why it's better. How many times do you use the local tram service? Oh, how many times a week? Oh, crumbs. There you go, that's the key bit there. And I've given plenty of option boxes there. They don't overlap. There's an option for none. If someone did use it 100 times, there's an option for them as well, because it's a 5+. 4 marks for that. You obviously get 1 mark for each of those, and you get 1 mark for the question, do include the timescale, and you get 1 mark for the answer boxes. There's sometimes when people do these, they end up drawing a data collection sheet. That's when they have a massive grid thing drawn out. You don't need that. It's for a questionnaire. That's what it will look like. Question number 8 over here. I'll read this out, although it is very confusing. Milk is sold in a half-pint bottle, 1-pint bottles and 2-pint bottles. One weekend a shop sold 100 bottles of milk. That's a very precise amount. 46 of the bottles were sold on Sunday. 15 of the bottles sold on Sunday were 2-pint bottles. 31 of the bottles sold on Sunday were half-pint bottles. Now when you get to this stage, you should be thinking that's really confusing. I don't really know what's going on. Because they've given you 3 options up here, look, half-pint, 1-pint and 2-pint, and it's talking about a weekend, and it's got a Sunday there, you need to spot the clue to use a two-way table. Now you can work it out without one of these, but it's an absolute pain, so it's best just to do this. And I'm going to fill it in with you here. So as we go down, we'll read it. So as you can see, I've got half-pint, 1-pint, 2-pint total, Saturday, Sunday total. So 100 shop sold 100 bottles of milk. So the total is 100, goes in there. 46 of the bottles were sold on Sunday, so Sunday is 46. 15 of the bottles sold on Sunday were 2 pints, so 15 goes in there. 31 of the bottles sold on Saturday were half-pint bottles, so that would be 31. Apologies for that, got cut off during the question. So that one there is 48. That makes this one here 31 add what is 48? 17. And from that you can actually start to work this one out. So 17 add 15 is 17, 27, 32. What do you add to 32 to get to 46? You add 14. So your answer is 14. I've written at the bottom. You don't even have to work these ones out, look, because you've got the question, you've got the answer you want, and it's 14 down there. Make sure it's a 4, don't make it look like a 9. Question 9 on the next page is this one. The diagram shows a container for oil. It's a cuboid. The container's empty. Sally has to fill the container with oil. A bottle of oil costs £3.50, and there's 300 centimetres cubed of oil in each bottle. That's 3 litres. She must not spend more than £60. All right. Well, if you see something like this, and they're talking about filling it with oil, when you fill things, it's volume. So you need to work out the volume of it. So the volume, I tell my students, you do the area of the cross section, which is this bit I'm shading in here. So 30 by 50 is 1,500 centimetres squared, and you times it by how far you go back, so times 40. A lot of wrong answers for this were 6,000. Be careful. 4 times 15 is 60. Then you put 3 noughts on it. So 60, look, with 3 noughts. So it's 60,000 centimetres cubed. Remember step 2, how much goes into each bottle? Well, it's 3,000 centimetres cubed. So how many 3,000s go into 60,000? What I did, look, I'm a bit cheating here. I crossed out them. I put 3 noughts and I crossed out those 3 noughts. You can cancel like that. So how many 3s go into 60? And it was 20. So she needs 20 bottles, so 20 lots of £3.50 is £70. Ignore the naught. 2 lots of £3.50 is 7. Then you put the naught back on, £70. And the answer is no, she'll be £10 short because she's only got £60. Again, I'll show you my workings there. This is another question with an asterisk at the top, as you'll see. So make sure you show your workings clearly. Next one, question 10. I'll just zoom in so you can see this a little bit. Expand x brackets x add 2. Well, x times x is x squared. X times 2 is 2x. So x squared add 2x, 1 mark. Expand and simplify. Let's have a look. simplifies what a lot of people don't do here, but we'll expand it first. So 3 times y is 3y, 3 times 2 is 6, 4 times x is 4x, and 4 times 1 is 4, but careful, it's minus 4 there, look. And now I'm going to simplify it. I've got 3 y's, so 3y, 4 x's, 4 x's, but I've got a 6 take away a 4, so 6 take away 4 is positive 2. So your answer is 3y add 4x, add 2. Next one, expand and simplify that one. 2t take 3, brackets t add 5. I use the grid method when I teach it to my students. So you're multiplying here, so 2t times t is 2t squared. T times negative 3 is negative 3t. 5 times 2t is 10t, and 5 times negative 3 is negative 15. Remember, positive times a negative is a negative. So I've written that out. 2t, take 3t, add 10t, take 15 over here. And again, you've got to simplify it. So you've got 2t squared, minus 3t, add 10t, minus 3 add 10 is 7, isn't it? Or you could do 10 take away 3, it still gives you 7, and the minus 15 at the end. D, factorize fully. So factorize means put into brackets. So what you do, what number is common in what are the common factors of 8 and 12? Well, there's quite a few that go into it, like 2 for example, but you've got to choose your highest one because it says factorize fully. So that would be 4. Are there any letters common? Yes, there's an A common, so 4a goes outside the brackets. So 4a times what gives you 8a squared. Well, 4 2's give you the 8. A times a gives you the a squared. And 4a times 3 gives you the 12a. And the one at the bottom is a bit nasty, this one I thought. You've got to factorise it, so put it into brackets. You've actually got to put it into double brackets because you've got a y squared and a y there. So you either sort of know that one or you don't really, but it's y take 2, y add 1. Or it's y add 1, brackets y take 2. You can check that by multiplying it out and you will get this here. Question 11. Oh, this was a fiddly question, I thought. Manchester Airport is on a bearing of 330 degrees from a London airport. So there's Manchester, look, and there's London, I've drawn it. There's the bearing of 330, and it says find the bearing of the London airport from the Manchester airport. So they're asking you for this angle in here. What I did was this. There's a few ways of doing it. I carried that north line down, like that, and because there's a north line here, we know they're parallel. So this angle here, which must be 30 because that adds up to 360, is the same as this angle here. So that's 30 in there, and that's a straight line, so it's 180. So 180 take away 30 gives you 150. I find drawing those out really, really helps. The next one is this. The London airport is 200 miles from the Manchester airport. A plane leaves Manchester at 10 o'clock to fly to London, and the plane flies at an average speed of 120 miles an hour, which is quite slow for a plane, I think. What time does the plane arrive at the London airport? Well, it's all about speed, distance and time. So there's your triangle, and it's after about time, isn't it? So what you do, you cover up time, and you're left with d over s. So time equals distance over speed. Plug your numbers in. 200 miles, 120 miles an hour. Now, because it's non-calc, that's quite tricky, but all I've done is just simplified it. So that simplifies to 20 over 12, 10 over 6, 5 over 3. It's a top-heavy fraction. By the way, if you've only got this far, it's a 4-mark question, look this. You're getting probably about 2 marks at least already if you got to this stage, so well done. 5/3, convert it to a mixed number. Basically, how many 3's go into 5? 1, and there's 2 left over, which is 1 2/3 of an hour. And you've got to just be aware that 1/3 of an hour is 20 minutes. If you think about it, 1/3 of 60 minutes is 20. So 2/3 is 1 hour and 40 minutes. But the question says, what time does the plane arrive? So it leaves at 10, takes an hour and 40 minutes, so it arrives at 11:40. I suppose you should put AM on there as well, just to show you know it's the morning. Next one. Complete the table of values. So we're going to draw a graph. It's quadratic, so it means it's going to be curvy because there's a squared bit there. Let me talk you through how I've done it. I always start this end because I find positive numbers are easier to deal with than negative numbers. Actually, you don't have to do the negative one, but we'll start here anyway. So it's x squared, take away 3x, add 2. So I substitute in this value of 4 here. So it's 4 squared, take away 3 lots of 4, so that's 12, add 2, and that gives you 6. Because that is 16, take away 12 is 4, add 2 gives you 6. And I've just done that for all of these, and these are the numbers I've got out of it. What you then need to do is plot your points. So I've done 2 marks on that top bit, by the way. If you get 3 of them right and 1 wrong, you still get 1 mark for it. Plot your points and draw your graph. You get 1 mark for plotting the points, and you get another one for drawing a nice curved graph like that. Don't do straight lines. Don't do feathering like this. All right, mathematically that's not very accurate. You should have a nice curved line like that. Okay. What you've got to do at the end there is, it says find estimates for the solution to the equation x squared, take 3x, add 4. Sorry, I'll zoom in, you probably read it better than I can say it. X squared, take 3x, add 2 equals 4. What you need to do is get your ruler, and you need to draw along where where y is 4. So there we go. And it's where it crosses the line. So the answers are, that is minus, I'd say, around 0.6. So minus 0.6 or 3.5, 3.5. So those answers are good enough for that. Question 13. Moving on. I always say these questions are fiddly. I thought this one was a bit fiddly as well. There's 18 packets of sweets and 12 boxes of sweets in a carton. The mean number of sweets in all the 30 packets and boxes is 14. So what I've done here, look, the mean average in total is 14. So that means there are, because there's 18 packets and 12 boxes, 18 and 12 gives you 30. 30 times the average 14, so there's 420 sweets in total. I've made a note of that. The mean number of sweets in 18 packets is 10, so I've done 18 times 10, 180. Now what I've done the total, take away the number of sweets in the packets to give me 240 sweets left in the 12 boxes. So there's to find the mean average, you do the total number of sweets in the boxes, divide by the number of boxes, which gives you 20. So there's 20, the mean number of sweets in the boxes is 20. This next one, where should we start on this? Right, these come up quite a lot, and there's lots of different ways of doing this with exterior angles and things, but I think the simplest way and the easiest way to explain it, if you're not sure about it, is to look at this. You're told you've got a regular pentagon and a regular octagon. That means all the lengths are the same, and that means all the angles are the same. All right, so a couple of key words there. So what I've done here, I've drawn myself a little chart, right? You know, in a 3-sided shape, a triangle, there's 180 degrees. In a 4-sided shape, there's 360. You might not know, in a 5-sided shape, there's 540 degrees. And what happens is, look, it goes up by 180 degrees each time. So, because we're trying to find an angle here, I've decided to work out what this angle here, Q, is. So in the pentagon, there's 540 degrees in total. And because there's 1, 2, 3, 4, 5 angles, I've divided it by 5. And that gives me this angle, well actually this one here, look, of 108. And I've done the sum there. In the octagon, so obviously the 8-sided shape around the outside, there's 1080 degrees, and you divide that by 8 because there's 8 corners in it. There's my bus stop method down there. Everyone have a quick look. 135. So what I've done is this. The whole angle here is 135. The red bit, so you can't actually probably see the red bit, the bit I've shaded in there is 108. So this bit here is, so 27 add 27 is 54. Scribble out the 154, got that wrong. So it's 180, take away the 54, and that gives you that angle in there, which is 126 degrees. A bit fiddly, that one. Question 15. Cumulative frequency, nice and easy. 1 mark for this, dead easy, it's just adding up. So you add up as you go down. So 19 add 17 is 36, add 15 is 51, add 12 is so on. when you plot this on the next page, you've got to plot 19 against 1. You plot 36 against 2, 51 against 3, and so on. So it should look something like this. It's that line going down there. Again, use a pencil and make sure you've got a nice line that goes through all the points. Don't use a ruler. It should be nice and curved like it is. So you get 3 marks just for filling in the cumulative frequency table and drawing the line. Dead easy. The one at the bottom says, let me have a look. Sue reckons that 75% of the parcels weigh less than 3.4 kilograms. Is she correct? This links into things like median and upper quartile and lower quartile, because there's 80 in total, right? So the median would be 40, and that's 50%, right? The lower quartile is 25%, which is 20, but actually the upper quartile is 75%. So this, what I've drawn here, is the upper quartile, but anyway, it's 75% of the 80 in total. So you go across, hit your line, come down, and it actually ends up on 3.7. So is Sue correct that 75% of the parcels weigh less than 3.4 kilograms? No, she's not correct, because 75% of the parcels weigh less than 3.7 kilograms. You might have got 3.6 or 3.8 depending on your graph, but that's how you answer that. 6 months. Moving on. What have we got here? We've got a trapezium and a trapezium there, and a rectangle there. Measurements are in centimetres. 2 shapes have the same perimeter. Work out the length of ST. Alright? So you're told that the perimeters are the same. Perimeter is obviously around the outside. So you need to work out what X is. What I've done, look, the perimeter of the trapezium is this. It's 7x take 2, add 5x, add 9x take 2, add 5x. And that is written here, look, there. The rectangle is 5x add 5, add 4x, add 5x add 5, add 4x. And we're told they're the same, look. So I've actually said, look, they're equal the same. So I've simplified that lot to get that, simplified that lot to get that, and then I'm going to solve it. So I've got 26x take 4 equals 18x add 10. Get rid of a negative, add the 4 to both sides. That gives me 26x equals 18x add 14, so add the 4 on. Take off the smallest value of x, so take away 18x, gives you 8x equals 14. Divide by 8, a bit nasty that. 14 divided by 8, well, I put 14 over 8. Simplified it, 14 over 8, 7 over 4 is 1 3/4. So x is 1 3/4. You probably got 3 marks for getting that far, to be honest with you, so well done. The question says, work out the length of ST. So you've got to substitute in your value of x, and we know that x is 1 3/4. So you've got to do 5 lots of 1 3/4, add 5. Let's have a look how I've done that. 5 lots of 1 3/4, I can't really do that in my head. So I did 5 times 1 is 5. 5 lots of 3/4 is 3 3/4. So that is 8 3/4. Then don't forget, you need to add the 5 on, because it's at the top, look. There you go, add that 5 on there. So the answer you get is 13 3/4, or 13.75 centimetres. 5 marks. A little bit nasty. Question 17. It's simultaneous equations, but it's a horrible one because it's got a fraction in it. So what I've done, first of all, get rid of that fraction. I know if you times 2/3 by 3, it will go to 2. So that's what I've done. But obviously you've got to times everything else by 3 as well. So 3 lots of that is 6x, 3 lots of that is 9y, 3 lots of that is 2. I've got to decide now, do I want to get my x's or y's the same? I reckon I can get my x's the same quite easily, because that's 6x, so I'm just going to double all of this. So that's why I've got 6x take away 8y equals 36. So now I've got my x's the same, I can sort it out. I've got to subtract, so 6x takes 6x goes away. Be careful on this bit, 9y take away minus 8y is 17y. Let me just write that out, what I've just said. I've said 9y take away minus 8y equals, and look, 2 negatives there actually make a positive, so you've got to add them. So 17y is minus 34, because 2 take away 36 is minus 34. Divide by 17, y equals minus 2. And you've got 2 marks for that. Now substitute the value of y back in. So I've just chosen 3x take 4y is 18, because it looked quite nice and small. So y is minus 2, so that's going to be 4 times minus 2 is minus 8. So I've got something in the box, I don't know it's 10 yet. Take away minus 8 is 18. So those two become an add. So what add 8 is 18? Well, it's 10, isn't it? So 3x is 10, 3x is 10, so x is 3 1/3. There you go. 2 marks for that, 2 marks for that. Next one, rationalize the denominator and give your answer in its simplest form. So rationalize means make it into a whole number, not a square root. So you convert this to the number 5 by timesing it by root 5 again, because root 5 times root 5 is 5. But whatever you do to the bottom, you've got to do to the top. So 10 times root 5 is 10 root 5. And I've noticed here, look, 10 divided by 5 is actually 2, isn't it? So the answer is 2 root 5 in its simplest form. If you get that far, you'll get 1 mark. If you get that far, you'll get both marks. And your answer goes down there. Question 19. Here we go. The diagram shows a solid shape. It's made from a hemisphere, so half a sphere, and a cone. The radius of the hemisphere is equal to the radius of the base of the cone, which you can see that because look, it fits on nicely. The cone has got a vertical height of 10 centimetres. The volume of the cone is 270 pi centimetres cubed. Work out the volume of the total shape. What I've done is written down the formulas for the cone and a sphere. I know it's a hemisphere, but I'll have it later. They're written in the front of your exam paper. What I noticed is that you've got to work out the radius, because you actually know the volume of the cone is 270. You know a third, you know a pi, you don't know the radius, and you know the height is 10. So here's my stuff for the cone. 270 pi equals a third pi r squared h. That's just the formula for it. What have I done? I've cancelled the pi's to start with, so that cancels, Then I've divided by 10. So that cancels and that cancels. Yep, that whole thing cancels. So you're left with 27 equals a third pi r squared times both sides by 3 to get rid of the third. So 81 equals r squared. So 9 is the radius, because you square root to go from there to that. So 9 is the radius. Now, because I know that 9 is the radius, and the radius, by the way, you should know this if you're doing this question, it's that middle bit to the outside, that is 9, and it's in centimetres. So the volume of a sphere is 4/3 pi r cubed, so we know that is 9. So it's 4/3 times pi times 9 cubed. I know that 9 times 9 times 9 is 729, because I did 9 nines are 81, and then I did 9 lots of 81 using the grid method. What I did next is, people don't like this bit, you've got pi there, that's fine, but you've got the 4/3. To find 4/3, I divide by 3, and then I times by 4. So there's me dividing by 3 to get 1/3, and times by 4, in this case I've just added 4 times, look. That gets you 972 pi for the volume if it was a whole sphere. But because, look, it's a hemisphere, you've got to half it, so you get 486 pi. The question says, what was the volume of the whole shape? So you need to do 486, add your 270, which you had before, so you get 756 pi. If you've got that, that's well done, that's 5 well-earned marks. Question 20, vectors. Here we go, let's have a look. So you've got a parallelogram. B, that's a midpoint, and that's a midpoint as well. Show that AMD is a straight line. So if you drew a line from here through M to D, would that work? You can't just draw it because you won't get any marks for it. So this is how I did it. I worked out what DM, no I didn't, I worked out what DA was first of all, because it's the easiest one, quite frankly. So to go from D to A, you go up here and you go along here. So it's 2B, add A, so 2B add 2A, and you can factorise it to 2A add B. So that is DA. Then I worked out DM, and I wonder if I can zoom out, you can still see my workings and still see the shape. We'll see how we get on. To go from D to M, first of all I went from E to B, And to go from E to B, it's 3B add A. So there we go, 3B add A. But because it's only half that distance, that's the midpoint, I've actually halved it. So it's 1.5B add a half A. So to go from D to M, it's minus B add what we just worked out for EM. So here's my workings. So it's minus B add what we just worked out there. I can't be bothered to read it out. But you simplify it and you end up with a half B add a half A. Again, factorise it, a half A add B. So from D to M, the direction is still A add B. I also worked it out for MA as well. So I worked it out for here to here. How I did that, MB, I've just worked that out actually, because it's the same as EM, because that's halfway. So MB is 1.5B add a half A, and from M to A you go up there, which is what I just said, and from B to A you just add on an A, look, because that's the midpoint again. So you add on the A, so you're left with 1.5B add 1.5A, factorise it, take the 1.5 out, so you're left with 1.5 brackets A plus B. And you proved it's a straight line because the direction is always A plus B. There's just the distance to 1.5 and a half that varies. Well done if you got that. Very difficult, 5 marks. I thought this was quite nice for question 21. I'll leave it there, I'll talk you. Okay, question 21. You're subtracting fractions, so you've got to get the bottom number the same. So what I've done there is multiplied this side by x and this side by 2 minus x to give me what I've got here. Because the bottom number is the same, you now just subtract away. So do the x's first. 5x take away minus 4x is actually 9x, because you're taking away a minus. And 5x, well, you've got a minus 8 there, so it's 9x minus 8. Bit fiddly with the negatives. And the bottom, you've got 2x take x squared. Probably get you 2 marks for that, but it says put it in its simplest form, so you can actually factorise the bottom, look, because x is common, so x brackets 2 minus x close brackets. Make y the subject of the formula. I'm going to go through this quite quick, my memory stick's running out. First of all, what I did was multiply by y add 2 to give me this, so ty add 2t. Then I've added 3y to get my y's on the same side, because we're making y the subject. Then I've taken the 2t off, so I'm just left with my 2 y's in here. So ty add 3y is 2, take 2t. This is a trick, right? Then I've factorised this side, so I brought the y outside the bracket, t add 3, close bracket equals. Then you divide by the t add 3, so you're left with y equals 2, take away 2t, divided by t add 3. And that's your answer, 4 marks. And this is the last one, I think, and this is a little bit fiddly, but I'll quickly get through it. The first thing I wrote down was that, because there's a cyclic quadrilateral here, first of all I should read the question out. Prove that the triangle BCD is similar to ECA. So there's 2 triangles here, there's a big one there, and there's a little one at the top there, prove they're similar. I've noticed that there's a cyclic quadrilateral here, so that means that that angle and that angle add up to 180 degrees, and this is what I'm going to use to solve it. So EAB, I've assumed that's x, that angle there, and if it is, that means BDA must be x take away 180, sorry, take away x, because they add up to 180. So that's x, that's 180 take away x. Therefore, angle BDC here must be x, because if that angle there is 180 take away x, and this angle here is 180 degrees on a straight line, this angle here must be x. So so basically this angle here and this angle here are the same. The same maths applies to this angle and this angle up here, and you'll obviously notice they share angle C. So and I've written all that down. So therefore both triangles have the same interior angles, so they are similar. I hope you did well. I'll put some grade boundaries up in a bit if I remember. Good luck.